So in the last part of the video we have learned about the basics of the HECRAS software. So we have learned about different tools and its functions. Okay, so in this part of the video we will learn the learn to how to build the study flow model, HECRAS 1D study flow model. Okay, so before that I want to share some of the in hydraulics behind the study flow, steady state flow. Okay, so for that I have brought you a illustrative sketch, okay, to understand the steady flow state, how it works. Okay, so here you can see I have a tank with a head some water and which is connected to a pipe. Okay, this is the tank and which is connected to bottom pipe. So here I will consider a cross section. Okay, so I will consider a cross section at this location. Okay, I will name this as section XX. Okay, so here if you take this section XX, there are the hydraulic parameters at this particular section XX. So they are, so one, if I note that here the hydraulic parameters which is coming here, write it here. Okay, so one is the discharge Q1. Okay, and the velocity V1. Okay, area A1, so this is the area of the pipe. Okay, and pressure at P1. Okay, so these are the parameters. If you consider the hydraulic parameter, if you consider the section XX. Okay, so if these parameters, so this variation of this parameter with respect to time is not change, do not change with the time. Say suppose 5 Qmax of the flow is coming. Okay, suppose I will give example that some 5 Qmax of the flow which is running through this pipe, and this 5 Qmax is the same for all 1 second, 2 second, 3 second, 5 second, or n number of time period. If the discharge remains the same and the velocity remains the same and the pressure rate also remains the same, so we can say that the water is flowing in a steady state. Okay, so that means to say in the equation term, if I can add that in the equation term, so with the differential equation term, that is dq by dt is equals to 0. Okay, so I am telling that the variation with respect to time is constant, that is there won't be any change in this parameter Q1, V1, A1, P1 remains the constant with respect to time. Okay, and I will consider another section here. Okay, at some distance. Okay, I will consider another section. That is, I will name this section as A. Okay, this is the next section in the pipe. Okay, after passing through XX, it will pass through the flow of the water passes through section AA. Okay, so for this AA section, the hydraulic parameter will be, I will name the hydraulic parameter here. So for this section 2 Q2 V2, that is the velocity at section A. The V2 is nothing but the velocity at section AA. Okay, A2 is the cross sectional area at AA. Okay, and the P2 is the the pressure rate at A. Okay, so if in the section AA, whatever the conditions which is coming flowing through this section XX, same conditions are passing through this section A. That means to say there is the change in the discharge with respect to time is constant, and change in the velocity, change in the area, and change in the pressure rate all remains the constant as of the section A XX. So then we can say this condition, this these two section, this part of the section is in steady uniform flow condition. Okay, so here you can